Alright, so today what we're going to be looking at is reminding you how we went through and we factored something, and then we were able to find all of this information so we could graph something. And what we would graph would end up looking kind of crazy, something like that, or something where they end up going like that with our end behaviors and our x-intercepts and all of that other information. But that's what we're going to be looking at for today and reviewing here. So I have a couple examples that we'll look at. What we're going to do is we're going to start by factoring them, and then we can kind of see where we could go from there with the information. The last thing that we'll look at this week is actually graphing them. But what we do is, if we're looking here at this first example, right, we have some function f of x, it equals 3x cubed minus 27x. The first thing that you want to do is look at that and think, can I factor that? Is there any way that I can break that down? And there is. Right, that's what we reviewed in our last lesson. You look at 3x cubed, you look at 27x, your first idea is, what do they have in common, right? What's our greatest common factor? All right, we look at 3x cubed, we look at 27x, we can take a 3 out of both of those. And also, they both have an x, so we can divide out a 3 and an x, factoring it out. That's your greatest common factor. So we end up with that 3x comes on the outside, and what's left over is 3 divided by 3 is 1, x cubed divided by x is x squared, minus 27 divided by 3 is 9. There's no x's left over. So good, we factored out the greatest common factor. We're left with 3x, and then x squared minus 9. But wait, there's more, right? You look, what do we have left in parentheses there? X squared minus 9. Now, if you remember back to what we did in that first day of review, x squared minus 9, it's a binomial, it has two terms. Can we factor that? And the answer is yeah, we can. That's our difference of squares. Right? We can look at x squared, and what we know is the square root of x squared is x, the square root of 9 is 3. So we can go further, right? X squared minus 9, factors into x plus 3, x minus 3. Okay, come on, Everly, you're off a little bit. Here we go. X plus 3, x minus 3, and that 3x that's sitting out in front stays out in front. That is completely factored, right? That's the first thing. We need to be able to get something completely factored, and we end up right here. Now, what all of that tells us, right? It tells us a lot of information. We can find the end behavior. We can find our x-intercepts, and that's the next thing I want to do, is let's look at that, and that's telling us some very specific information about our graph. Each of these individual factors here is telling us an x-intercept, right? That first one, 3x, right? 3x, we set that equal to 0. 3x divided by 3 we divide 3 on both sides, 0 divided by 3 is 3. We have an x-intercept at 0. We can do the same process with each of those other parentheses. X plus 3 equals 0, x minus 3 equals 0, and we can solve those. Right, we have x equals negative 3, x equals positive 3. Those three values right there tell us a lot about our graph. Those are our x-intercepts, right? So if you remember, what that would tell us is we're not going to do a graph again. I'm saying that right now. But if we did have to do a graph, we now have x-intercepts at 0, at 3, and over here at negative 3, right? That's where our x-intercepts are. So we know that our graph is going to go through and do some crazy stuff at that point. Now, we have a lot of other information that we could find, like the end behaviors and stuff on top of that, but for right now, I'm just concerned about the x-intercepts. So we find the x-intercepts. The only other piece of information we would like to look at for our x-intercepts was, does it bounce or does it pass through, right, the x-axis? And if you remember, what tells us that is when we go back to the beginning and we look at these three specific factors here. It's what's the multiplicity, or what's our exponent, right? For a bounce, it had to be, let's say, even exponent. For it to pass through, it was an odd exponent. So we look at these three. Yes, those are threes. That's not the even or odd I'm talking about. I'm talking about this one here, or this one on those two factors. They all have an odd exponent, meaning that for 0, -3, and 3, they will all pass through. Right, so that's when we put pass, pass, pass. And we could start kind of having an idea of what our graph will look like. Right, now if we sketched it, it will look something like, pass through means we go through, something like that. But we don't know the end behaviors. That's the next step that you would take for graphing. Right, the second example, we'll go through it a little bit quicker. Same concept, right? You look at it. We start by looking at x squared minus 6x minus 7. First, can we factor that? Yes, we can, right? We look at it, that's our diamond method. Two numbers that multiply to -7 and add to -6. What two numbers multiply -7, add to 6? Obviously 7 and 1, but we need it to be negative, so one of them is going to be negative. That's a 7. -7 plus 1 is -6. -7 times 1 is -7. So we can break that into its factored form of x minus 7, x plus 1, right? That's where we end up. So our function, sorry, I don't even have that up here. It's f of x equals, is represented by that. And again, just like we did on that left-hand side, we can find what are the x-intercepts. Does it bounce or pass through? That's the main information that I want to look at here. So we break it up. We got x minus 7, x plus 1. You set both of those equal to 0. We get x equals 7 and x equals -1. Right, by subtracting 1, adding 7, those again are your x-intercepts. So again, if we were looking at a graph, right, we could go over here and say, oh, I know that at 7 and at -1, I have x-intercepts. So we automatically get those 2 points right there. The second thing, figure out if they bounce or if they pass through. And just like we did on that last example, you can look and see what exponent does each of those factors have. Again, they both have an exponent of 1, which means pass through for both. So if we added on there, we'd say pass through, pass through. Now, I know we didn't look at one that was different. When it is not pass through, that's when we end up with, instead of, let's say, x plus 1 there, we had x plus 1 squared, right? Then that means that at -1, we would be bouncing instead of passing through. But we don't have that. We have that at +1, or sorry, at -1, it's already an odd exponent, meaning it passes through. Again, that tells you your x-intercepts and determines if you bounce or pass through there. The last thing that we have to do here for this specific example, is you look at it and we have to figure out what's the y-intercept. Right, now we didn't have to do that for the first example. The y-intercept was at the same place as the x-intercept. It was at 0. But we don't have that point. We don't have this point 0, 0. So we find the y-intercept. To find the y-intercept, that's when we just set x equal to 0, right? So you go to your equation. It doesn't matter which one you choose. You can choose this or you can choose that. But what I'm going to do is I'm going to take this x minus 7, x plus 1, and just plug in 0 for x, right? So we plug in 0, 0 minus 7, 0 plus 1. That's what? Negative 7 times 1 is negative 7. What that means is we now have a y-intercept. It is negative 7. So if we were to slap that guy on the graph, a y-intercept of negative 7 would be right down here. That's your y-intercept. Now again, we're not going through and doing the graph, but we have an idea of what it could look like, right? It could look anything like this, right? But we don't know the end behaviors. Again, all I want is us to factor it completely, find the x-intercepts, right? Just like we did here, found their x-intercepts of 7, negative 1, and determine will they be bouncing or will they be passing through, right? If we don't have the y-intercept at 0, 0, we go through, find the y-intercept. Again, that was this process. You set x equal to 0, and you simplify. If you have any questions, please feel free to reach out to me. I know we're going through a very interesting time. I'm available to help you guys out, and email me. Have a good day.